Hello everybody, welcome back again. Spoiler alert before you go and watch the rest of this video. I mean, I know that's not what YouTube wants me to do. Of course, they want me to want you to watch the whole video. But brief spoiler alert, changing the bulbs for LEDs didn't quite work out. So I decided not to finish that little bit of project, and instead I'm going to work on sourcing some original bulbs. But I had recorded all of that, and I thought that there was some interesting tidbits in there, like how I was calculating which resistors to use and things like that that I thought were still worth sharing. And if you watch the video, you can see all of that, and then you can see why I decided not to move forward with it in the end, even though it does technically work. This is me from the future. The rest of the video is me trying that experiment and ultimately deciding that I didn't love it. At the end of my last video, I mentioned that I was going to try to replace the bulbs in the VU meters with some sort of amber colored LEDs. And so I picked these up pretty cheap, come in like a bag of 100. I just got them from Amazon because I don't have a local electronics supplier. I really miss my old electronics shop in Tucson, Elliott Electronics Supply. I could still order things from them, but delivery takes a while to get all the way over here, so haven't ordered anything from them in a while. Anyway, I'm gonna try to put a couple of these in place of the old bulb. And I'm thinking I'm gonna do two and kind of do them pointed at each other like this, so that we get the same kind of more wide beam instead of a sharp point. You should get like a little more coverage. So the first step is to calculate what our series resistance needs to be, and I guess I just thought I'd go over that real quick for anyone interested. You can look up calculators for this stuff easily, but I find it pretty interesting and like to sometimes do things a little bit by hand, just for keep my brain working sharp. So you can see the forward voltage on one of these is 2 to 2.2 volts, and the forward current is 200 milliamps. I measured on the VU meters that the source voltage was 6.5 volts. I think it was actually like 6.52, but this will be close enough. And we're gonna put 2 and the resistor, because if we just put 6.5, even with 2, that's only 4 volts. We'd probably blow them, because we'd be overpowering them quite a lot. We could put 3, but that starts to be cumbersome. Probably wouldn't need a resistor at that point, maybe. But the circuit's gonna look like this. We'll have our 6.5 volts coming in, then we'll have a LED. This is the circuit symbol for an LED. Then another LED. And then our series resistor that we want to calculate. So our source voltage is, this is an S, my handwriting is terrible, 6.5. Our total forward voltage is gonna be 4. I think we'll just go with 4 because it says 2 to 2.2. So we're just gonna say 4 volts, because that's 2 times 2, and it's 2 volts on each one. And then that leaves us with our voltage across our resistor. Like these are if you were measuring your terminals here. So then our voltage across the resistor is basically, it's the voltage divider, right? So it's whatever is left over. So 6.5 minus 4 leaves us with VR of 2.5 volts. We know that our forward current is 20 milliamps. So we know that we want 20 milliamps flowing through, we know that the voltage across the resistor, it needs a voltage drop of 2.5 volts, and we can use that to calculate the resistance using Ohm's law, V equals IR. We know the voltage. In this case, it's 2.5 volts is equal to 20 milliamps. So in Ohm's law, the I is in amps, so it's 0.20 times R. So then to solve for R, basic algebra, 0.20. So we'll end up with 2.5 divided by 0.20. That's 125, 125 ohms. So what I'm gonna do is I'll take and do basically I'll set these up like this. Is that the short side? Long side, okay. So then here I would do short side. Okay, now I'm over in my little studio office where I have the mixer just kind of chilling while it was waiting on this bulbs to come in. And I have this trusty Pine-Sol, I think they call it. It's an amazing little soldering iron. It's powered by USB-C. I bought it a year and a half ago. I've used it to assemble so many DIY modular kits. I've used it to do so much work on my cassette machines. It's really amazing. It only costs 40 bucks. If you don't, or that's what it cost me at the time. If you don't have a soldering iron, I don't see any reason you would buy anything other than this. I just plug it right into my MacBook power supply brick here. So I don't need to buy a power supply or anything. I'm sure you've got a USB-C power if you have a reasonably recent computer. It might even work off of a smaller brick. I'm not sure how many watts this thing requires, but it heats up really quick. It lives in this little carriage here between the tip. I do have some other tips. They're in the little storage box over there, but I pretty much always use this one. Anyway, so real quick, I'm just gonna pop one of these bulbs off so I can use it to do the spacing for how wide to put the LEDs.
They're just surface. They're not even through holes. They're just little surface pads. So it's gonna be real easy. Maybe there is a hole in there. Can't really feel it. Okay, so we got this bulb out.
You can see it's blown there. The black in the middle. No good. Alright, so here's our bulb that we pulled out. Here's our two LEDs that I've already kind of bent into a rough estimate of how I'll have them oriented. See, basically, to get similar width, they just need like a very tiny little bit of a gap. Hopefully that works out. I have this resistor kit that I bought from Spark Fun probably, I don't know, 15 years ago. And I mean, I use them, I've been using them for everything. I've used them for so many little projects. It's just such a nice little convenient book. But there's nothing around 125. Only, oh no, that's 100K. Hold on. Maybe I'm wrong. 10. See, we've only got 100 ohm and 220 ohm. So I don't quite have in this kit what I need. But I do have this trusty bag from my friends over at, I mentioned a second ago, LA Electronic Supply, Tucson, Arizona. Shout out. $7 for all these resistors I bought at some point before I left, because I went there and I was like, you know, I'm probably gonna need some resistors, and I'm moving in the middle of nowhere. So I'm hopeful that maybe I can find in here. Oh man, these are all they're all large, like K's of resistors. I didn't know that when I bought it. I just assumed it would be a little more general purpose, but that's okay. I'm not gonna buy resistors just for this. I want to get it done. So what I think I'm gonna do is I'll just use two different resistors because we've got 100 ohm. Dang, we don't even have a way to easily get to 125 from 2. Bummer. If you remember, another thing to keep in mind is that this can go all the way up to 4.4, which would make this 2.1. So then we would end up with 2.1 divided by 0.20. Because the voltage across the diode is 2 to 2.2, and I did this math just on the minimum. So if we put it at 2.2, that would be 4.4. 6.5 minus 4.4 gives us 2.1 left over. 2.1 divided by 0.2. What is that? 105? And we do have 100 ohm. Be a little high. But we could try it with I'm gonna try that. If we fry an LED, we fry an LED. It doesn't really matter. 100 ohms is brown, black, brown. Okay, we're back over here at the board. One thing I didn't mention is polarity, because LEDs have polarity. And actually, let me just go get an unsoldered one. If you look real close, you can see one leg is longer. That's the positive leg. And in the case that if your legs have been snipped, there's also, it's really hard to tell on these clear LEDs. And is it gonna focus? There's a flat side. Oh. There we go. There's a flat side on the LED. The flat is the negative. And so if you hook a LED up backwards, nothing will happen. So one thing I want to do is determine the polarity. I'm going to guess that the right side is positive here. So go. So there's our 6.52. You can see that's positive because if I switch it, see that negative symbol just above the DC on the meter? So this is the positive side on the right, which means we want, and when I soldered these together, I did, this is the negative side coming out the positive side into the negative side of this one, and out the positive side, and the resistors, their orientation doesn't matter. So I have the board powered up. As you just saw, we were measuring. So what we can do, maybe, is just even just touch it. Maybe this is a little risky, but maybe some pro engineers out there might be like, what are you doing? But I think it's worth it just to do a little test. We'll see if we get some. Yeah, look at that. Let there be light. Okay, so I'm gonna solder these up. Power off for solder. And then I'm gonna have this metal in the way. But maybe what I can do is just rotate like this on this one. Like so. So that we're kind of coming out like this. And just make sure that we're not touching here or here. We're not shorting something out. Now let's see how that lines up. Now let's flip it back on. That's gonna look pretty good. Kind of need to do a little bending, placing. I don't know. Maybe not. I'm not sure how I like that. It's not really not even light. Maybe I need to rethink the orientation. Consider just doing them pointing straight up. Because it's not, I don't like the way that look. I don't like the way that beam pattern looks. So I'm gonna rethink that. Might do it differently. This is why we experiment. Because maybe we'd like it better if we were oriented more. I mean, it could work out. It could be okay because the little plastic covers have this foil inside that might create some reflectivity and look pretty good. I don't know. I'm gonna think about it. Do some experimenting, and I'll come back when I have a final solution.